Okay, welcome back to the channel. We're now going to modify a single stage amplifier in order to document two component changes. Now what we've got here is multisim running with a single stage amplifier with the same values as your circuit design. If you click on the oscilloscope function, what you'll find is that it will show you this waveform, and from that, if you can see two tabs in the top left hand corner, this now enables us to drag these across and analyze some values from the output waveform. Channel B is our output. As you can see, it runs from the top of the collector of the transistor into channel B of the oscilloscope. Channel A is our input, fed from our function generator, and then goes into the input of our circuit. So we're analysing channel B in order to ascertain the gain of the amplifier. This is the output voltage and this is the input voltage. As you can see, this one is greater, and in order to work out the gain of the amplifier, which is how much greater the output is compared to the input, gain is equal to output divided by input. Just one thing to note, your input signal is in millivolts, so you'll need to convert that into whole volts before conducting your gain calculation. Gain is a unitless quantity, so it will just be expressed as a given value, normally between kind of 130 to 150. Now the task asks you to modify it by changing a minimum of two component values. In order to do that, you stop the simulation, double click on the component you want to change, type in a new value, we're going to choose 50k, hit OK, and then restart the simulation. Now as you can see now on the oscilloscope, this has quite a profound effect on the output waveform of our amplifier. Also, you should be able to see that the bias voltage going into the base of the transistor has increased, therefore has caused the transistor to be pushed out of its active zone, and then the effect of that is the distorted output waveform. Your job is to research why that's happened and why it causes that output distortion. What we can also do is reanalyze the waveform in order to recalculate gain. Now clearly we can see it's only amplifying half of the waveform, so we're not going to get as much gain, and as you can see there, we've lost at least a voltage output. What we now need to do is choose another component to modify. Now what I'd recommend before we do that is stop the simulation again and reset the circuit back to its original values. This makes it easier to document changes because we're now going to be working with, when we press run again, a fully working amplifier circuit. What I'd recommend is that we start looking at capacitor number 2, and the reason for that is we can change this value, and as part of this output filter stage it will have again quite a profound effect on the output of the amplifier circuit. Now we've gone from 10 microfarads down to 1 microfarad, just reminding us there to stop and start the simulation, and as you can see now it's just reduced the size of our output signal. We can document this by taking the tabs, scrolling them across, and then recalculating our gain. But again, you can see that by reducing this capacitor number 2, it has reduced the gain because the output signal is a smaller amplitude. What I would recommend is that you do some research with regards to what that capacitor does. Essentially it is separating AC and DC components, and then also you can back this up with the theory by working out your capacitive reactance for different capacitor levels using the 1/2 pi FC formula, and then that will back up your testing, take screenshots, and then also document it in a report style in your assignment.